Hey everybody, today you're going to be performing the Center of Mass lab. Normally I wouldn't leave a lab for classes if I'm not going to be there, but two good things are going on. One, this lab is super easy to perform, and two, you guys are awesome. So the lab involves these cardboard systems that you can find in the front of the room. They all have different masses, different shapes, and the goal is to figure out where the center of mass is for each of these systems. Center of mass is a great physics concept because you can describe the center of mass just by physically handling these objects and figuring out where they balance. You can describe it mathematically with equations, and you can describe it with words to explain why the center of mass is where it is. And today you're going to be doing all of those in this lab. The first part of the lab involves grabbing a system. It doesn't matter which one you start with. You can start with any, and you're going to be looking at 4 today with your group. Then you're going to sketch your system on this little grid. I did an example problem where I made this sketch right here. I drew this system out, and I labeled an x equals 0, an x-axis, a y-axis, and then a position where I think the center of mass would be with a little like gray dot. The darker gray dot that you see on here is going to come later. After you actually calculate the location of the center of mass, you'll go back to your sketch and compare it to your predicted center of mass. For the first one, just guess. You can sometimes have an idea as to where a center of mass will be without actually physically doing some exact calculations. Those exact calculations come next when you're going to sum the mass multiplied by the position and then divide that by the sum of the masses. That's the same formula that's detailed in the center of mass presentation that is also posted on Google Classroom. Your group this is a great opportunity to talk to your group about the calculations you're doing to figure out where the different masses are. Each of the grids are 5 centimeters by 5 centimeters. So when I set my x equals 0 axis right here, I was able to count and go 2.5 centimeters, 7.5 centimeters away, 12.5 centimeters away, and 17.5 centimeters away to sum all of my mass positions. Remembering that the mass that I have at 17.5 centimeters away from the axis is 2m. Then I divided that by the total mass of this system, 5m, and I figured out that the horizontal position of the center of mass was at 11.5 centimeters. The vertical center of mass for this one was pretty easy because I just set the y equals 0 axis right here, and I was able to see that everything is at y equals 0. This thing was symmetrical vertically. So it was pretty easy to do the vertical center of mass calculation for this system. Then, to test if my answers are correct, you don't need a solution guide. That solution guide is right here. You can take your system and balance it. And I'm balancing mine right here. And that's nice because this is exactly where I thought the center of mass would be in my calculations. It's not at the exact spot of 10 centimeters, the center of this thing. It's a little shifted this way, which makes sense considering this mass of 2m. If at this point, if I couldn't balance it where I thought the center of mass was, then this would be a great opportunity to go back and check the calculations. Because physics is telling you, wait, something's off. The exact spot where it balances should be the center of mass location. There's one system in the front of the room that won't balance because the center of mass lies outside of the actual system itself. That's totally okay for systems to do, as we saw when we calculated the location of the center of mass in the presentation. Sometimes the center of mass isn't where any mass is. That's fine. But you'll know which one that is. It's the one that looks like a boomerang, and it kind of makes sense that the center of mass isn't where the mass is. Then, the next part of the lab involves a qualitative explanation, where you can use words to describe why the center of mass is where it is. A few sentences are good here, but definitely include specific references to your system. In this case, everything I said before holds true. I knew the center of mass wasn't going to be right in the geometric center, but shifted more towards the side of 2m because there's just more mass concentrated on this side. Then you and your group will go up and grab another example mass, and your goal is to look at 4 different systems today. After you do the first one, the other 3 are exactly the same, but you can continue to see other patterns in different systems and talk about the center of mass with your group. And that is our lab for today. Be awesome. Take care of these cardboard things. Don't bend them or try and bite them like they're chocolate bars. And I'll be able to do this lab for years to come with students. Thanks, and I'll see you next class.